Welcome back. I hope you've had time to do problem 6. So let's talk about it. So in the diagram, we know AB is 24 and CB is 25. What is the length of the radius of the circle, and what is the measure of angle ABC? In other words, theta. Well, obviously I draw the radius from C to A. And so then we have a triangle. Well, we don't know anything about any of the angles inside a triangle. So I think back to the theorems that we have dealing with circles. And that there's a theorem that says if you have a tangent line and the radius drawn to that point of tangency, that forms a right angle. So we now have a right triangle, and we know one leg and the hypotenuse, and we want to find the other leg. This other leg, I could have labeled it as B because it's opposite angle B, or since it's the radius, I could have labeled it R. I'm going to go with R because the question asks what's the length of the radius. So if I look at my right triangle, I can use the Pythagorean theorem. So a squared plus b squared is c squared. So 24 squared plus r squared is 25 squared. And I solve and I get the radius is 7 units, whether it's inches or feet or meters or centimeters or whatever. Okay. And then it also asks if we can find the measure of angle B. So we know this is a right triangle, so we can use SOHCAHTOA. And we know the adjacent side and the hypotenuse. Adjacent, hypotenuse, that's our cosine. So cosine of B or cosine of theta, whatever you want to label it, is equal to adjacent over hypotenuse, so 24 over 25. Take the inverse cosine of both sides, and you end up with 16.2602 and so on degrees. Okay, so that's problem 6. Problem 7 is a little bit similar to problem 5 in the sense that you need to find at least one of the diagonals. And then once you have the diagonal, then you can do something to find the area. And so that's going to be my hint for you. So please take a look at problem 7, do it, and then come back and let me come back and watch the next video.